Jakarta is sinking faster than any other megacity on Earth, with northern districts dropping 25 centimeters every single year.
Uncontrolled groundwater extraction, combined with global sea level rise, threatens to submerge the homes of 10 million residents.
During high spring tides, seawater regularly breaches coastal defenses, flooding commercial hubs and residential neighborhoods.
If left unchecked, northern Jakarta could be 95% underwater by the year 2050.
To avert catastrophic erasure, Indonesia launched the National Capital Integrated Coastal Development Master Plan.
Priced at $40 billion, the centerpiece is a colossal outer seawall stretching 32 kilometers across the bay.
This multi-stage mega-project combines coastal dikes, offshore retention lagoons, and massive artificial islands.
Financial backing brings together international engineering consortiums from the Netherlands, South Korea, and Japan.
13 major rivers dump urban runoff into Jakarta Bay, creating complex water management challenges inside the wall.
Hydrographic survey fleets map the soft marine clay seabed to design foundations capable of supporting heavy concrete walls. The master plan is divided into 3 critical phases to provide immediate, midterm, and long-term flood security. Phase A, reinforcing 46 kilometers of emergency coastal dikes along the immediate shoreline. Phase A focuses on driving thick concrete sheet piles deep into the shoreline to prevent immediate ocean breaches.
Heavy hydraulic hammers drive 20-meter concrete piles into soft mud strata to reach stable, bearing soil.
Elevated 5 meters above sea level, these coastal walls act as the first line of defense for low-lying urban areas.
Geotechnical tests show the seabed consists of extremely soft alluvial silt, requiring deep soil consolidation.
Deep cement mixing rigs inject cement binder into soft clay, creating thousands of subterranean rock columns.
Heavy geotextile mats and basalt armor blocks are placed along the dike toe to stop tidal current erosion.
High-capacity pumping stations work constantly behind coastal dikes, pumping trapped urban rainwater out to the sea. Automated trash booms remove hundreds of tons of floating river waste daily to keep drainage pumps operational. Flexible expansion joints allow concrete dike sections to absorb minor ground movements without cracking.
Engineered mangrove wetlands are restored along dike edges, using nature-based solutions to trap sediment and dampen waves.
Stricter regulations on industrial groundwater extraction aim to slow ground sinking rates across the metropolitan region. Phase A buys crucial time, but long-term survival requires Phase B, the giant offshore outer seawall.
Phase B moves out into open waters, constructing a 32-kilometer offshore barrier wall across Jakarta Bay.
Fleet dredgers pump millions of cubic meters of sea sand to form stable underwater embankment bunds.
Onshore dry docks precast giant hollow concrete caissons designed to serve as the core wall structure.
Heavy tugboats tow 20,000-ton concrete caissons out into open bay waters with millimeter laser positioning. Ballast tanks fill with seawater, sinking caissons onto underwater gravel beds with high structural stability.
Rock dumping vessels deposit thousands of tons of granite boulders to protect the caisson foundations from scour.
Connected caissons form a continuous outer barrier wall standing 7 meters above the sea surface. 17 artificial reclamation islands are built adjacent to the seawall, creating new urban land for commercial expansion.
GPS-guided heavy bulldozers level millions of tons of dredged sand to build stable artificial island terrain.
Vibro-compaction rigs stabilize loose sand deposits, preparing artificial island ground for skyscraper construction. Massive steel storm surge gates are installed along primary shipping channels to maintain commercial vessel access.
With the outer wall sealed, Jakarta Bay transforms into a giant enclosed freshwater retention lagoon.
Enclosing the bay creates a massive challenge. 13 rivers continue dumping billions of liters of river water inside.
To prevent internal flooding, The world's largest pumping station complex is built into the outer barrier wall.
Gigantic electric pumps, capable of moving thousands of cubic meters per second, flush excess river water out to the sea. Industrial electric turbines, powered by dedicated substations, maintain constant water levels inside the retention lagoon. Automated sluice gates open during low tides, utilizing gravity drainage to reduce electricity demand on the pumps.
Desalination and water treatment plants purifies the lagoon's water, converting river runoff into clean drinking water.
Advanced filtration systems supply clean piped water to North Jakarta, eliminating the need for illegal groundwater wells.
Floating solar panel arrays generate renewable energy while reducing water evaporation across the freshwater lagoon.
Automated sensor buoys monitor water quality continuously to prevent pollution buildup in the enclosed bay. Artificial recharge wells pump treated water back into deep underground aquifers, stabilizing the sinking landmass.
Inland, urban river channels are widened and dredged to speed stormwater flow toward the seawall retention basin.
The retention lagoon provides a calm, controlled water body, completely eliminating ocean storm surge risks. Indonesia combines seawall engineering in Jakarta with relocating its political capital to Nusantara in East Kalimantan.
Moving government administrative functions to Nusantara reduces population density and environmental pressure on Jakarta. The seawall crest hosts a 6-lane highway and railway line, connecting eastern and western coastal regions directly.
Reclaimed artificial islands develop into vibrant commercial centers, housing thousands of tech hubs and waterfront apartments. An integrated AI command center tracks water levels, ground movement, and pump operations across the seawall network. Comprehensive clean water piping reaches every North Jakarta household, successfully ending dependence on private wells.
Once flooded coastal communities now thrive behind secure seawalls, protected from daily high-tide disasters. Restored coastal wetlands filter urban runoff naturally, boosting marine biodiversity inside Jakarta Bay.
Data confirms land sinking rates have slowed dramatically, stabilizing Jakarta's coastal ground foundations.
Engineers worldwide study Indonesia's $40 billion seawall as a masterclass in megacity coastal adaptation. A monumental $40 billion engineering shield, ensuring Jakarta remains safe, resilient, and prosperous for centuries.
Across the coast, these massive engineering marvels stand ready against rising tides, proving that human determination can save a sinking city from the sea.